Hello guys, and welcome to another practical video tutorial, and in this one we're going to talk about packet captures and WireShark in particular. So first of all, what is a packet capture? When you are on the network, you are actually communicating with other hosts on the network or outside of this network, and you're doing that through packets. And a packet is a network segment, is a network part of the network, and it's used between different applications and different tools to communicate. Like for example, your browser is sending packets to a server on the internet, and this server is sending packets back for you to read them, and your browser interpreted these packets for you, so you can actually read the content of these. And what is WireShark? WireShark is extremely powerful network diagnostics tool, and it's being used both from hackers, penetration testers, network engineers, people just in their homes for doing network checks and some sort of analysis and things like that. So it's really powerful, and it's also a multi-platform. It's cross-platform tool, so you can run it on a Windows machine or a Linux machine, and of course on a Mac. I don't know if there is a mobile version for now, but let's just go ahead and skip that part. So as you can see, I'm on my Linux machine. I don't need a virtual machine for that test because I have WireShark on my laptop anyway. So first of all, if you want to install WireShark, you can do that. I'm using Ubuntu, so you can do that from the repository. It's really simple. If you just use apt, for example, search, and if you're looking for WireShark, and I'm looking exactly for WireShark, I don't want to get all the results related to WireShark. This is the packet that we're talking about. I already have that installed. Let me just check that out. WireShark. Yeah, I have an eye in front of it, which means that it's already installed. It's a network traffic analyzer, so on and so forth. So to run WireShark, what you need to do is, first of all, since if you want to run WireShark, you can run it in a mod that's going to listen on some of your network or all of your network interfaces and capture packets or check them in real time. What you also can do is save those packets after that, and of course you can open WireShark and read from packets. So if you for example have some packet dump using WireShark or TCP dump, and it's saved in a PCAP file or CAP file or something like that, and if you want to read that packet dump, you can use WireShark to read those packets, and it has a very powerful GUI. So let me just start it up. If you want to be able to capture packets on WireShark, then you should be able to run it as a root or using sudo in my case. And I'm typing the password. If you don't run it as root, it will not find any interfaces. Since I run it as root, it found all the interfaces that I have here. So what I'm looking for, I'm going to, as you can see, we have traffic. There is it shows a little bit of a graph here. That's the IP address and the MAC address. There is currently no capture filter here, and it shows that there is some sort of traffic going on this interface. There is also some sort of traffic on the loopback interface for some reason. I don't know what's that, but let's just check out and start listening on the wireless interface, because that's where all my traffic is going through at the moment. So if you double click on it, it will open that window, and as you can see here, that's all the packets going on through that interface at the moment. And there's a lot of information going on here, so you might not be able to analyze that as fast as it goes, and that's the reason why you can always, when you do stop, you can always do a save as, and you can save that information as a packet. So for example, I can save that here as a, let's just use it, wireshark.pcap. And all these packets are now saved on my machine as a PCAP file, and I can analyze that. I can now close WireShark. I can run it without being root, and I can just use file, open. There's the recent file, and that's all the same packets that I just got captured a few seconds or few seconds ago. So that's another thing you can do. Keep in mind that if you're capturing packets, and if that's on a busy network or a busy interface, those files can grow really big. So keep that in mind if you're using it for some sort of network analysis or network troubleshooting. Make sure you have a lot of space aside for that kind of capture. It's going to take a lot of space. So let me just run it as root again, so we can work with live data. It gives you a warning the first time you run it as root. It tells me something about some file being disabled due to running WireShark as a super user, but that's okay for us. So we start listening on the wireless interface, and what you can do here up top, on the top, you can actually write filters, and it's really powerful. There are a lot of filters that you can use, and so first of all, let's start with the simple one, which is an IP address, of course. So it's going to be ip.addr for address equals, and now you type the IP address of the host you're interested in. So let's just try with 192.168.1.4, for example. When the filter is complete and it's properly entered, you can see that it moved to green. If I delete the last octet, because an IP address needs 4 octets, it's in red and it's not going to work like that. But if I enter the 4th one and hit enter, here's the filter working. So I can see that either the destination or the source has the IP address that I'm interested in. Another thing you can do is you can use a port, for example, TCP port equals 53. Sorry, that's UDP port equals. One important thing, to add additional filters, you need to use either AND or as a statement. So I want to look for AND, which means that I'll be looking for that IP address and connections on the TCP or UDP port that I'm interested in. So now if I do UDP port equals 53, that's only DNS traffic for the IP address that I'm interested in. And as you can see here, that's all DNS requests. It's asking for A records, that's the Skype, C names, things like that. So this is the traffic on port 53 for the IP address .1.4. It's really powerful, as I said, and of course you get to right click and do a lot of other things. But let's just look for TCP traffic and see what other powerful thing we can do. So, and TCP port, let's try with 443. So this is going to show all the traffic on the 443. If I do right click and click on follow TCP stream, it's going to show me all the traffic on that port. Now, as you know, 443 is a SSL encrypted web traffic in most of the cases, and this means that since it's an encryption applied on that, I won't be able to read that traffic. WireShark does not decrypt that for us. But that's the traffic here we have, and you can look at the entire conversation, which is 28 megabytes. You can look for one of the IP addresses to the other one, like for example the source talking to the destination, or the other way around, the destination responding back. And of course another thing you can do is you can show the data. This is an ASCII representation of the data. In this case, it won't really do any difference because we won't be able to read the encryption information here. But for example, you can do a hex dump, and in many cases, hex is really useful when you're analyzing network traffic. And of course, you can get a row, which is again hex. So let me just, and as you can see, the filter changed to TCP stream equals 1. Which is one of the TCP streams. WireShark is actively indexing those streams, and if I change it to 2, or yeah, TCP stream equals 2, it gives me a different stream between well, in this case it's the same host, but it's normal because that's the IP address of the machine that I'm running it. So this is another way to actually look for specific traffic between hosts in that network and in that capture. Another thing you can do when you're using WireShark is you can look for statistics. This is also really helpful. One thing is endpoints, and these are all the addresses that are part of the network. This is the TCP. You can get to IP, and then of course Ethernet. This is the MAC address. This is the physical layer, the network layer. Another thing you can do is in statistics, you can go to conversations and you can get all the conversations that are actually going on between different hosts, and you can use that as a filter, and you can get all you need here. You can go to UDP, you can go to wherever your needs are. It's really powerful tool. Let me see. Well, you can go to resolved addresses, and this will give you information of the actual resolutions that are here. So really powerful. As I said, you can look for strings here if you're interested in part of the packet. So let's say we are looking for Google. So let me just check out what was the filter. If you want to look through all the options you have for searching, you go to expressions, and here you get to choose from the huge amount of filters that you can apply for different kinds of packets, different kinds of networks. Everything is here. So if you look for string, let me see if I can find something in expressions, because I want to look for a specific string. Yeah, for example, SSH protocol, all you need. So let me try it and type Skype and see if it's going to look for that string directly. Okay, so TCP. These are all the filters you can do with TCP. Port, you can get to different options. You can look for TCP flags. As it is here, you can see TCP flag, TCP options, port stream. Okay. Let's look for traffic that we would be able to read. TCP port equals 80. We don't have any traffic on port 80, unfortunately. I don't have any browser or anything open up, so that won't work. But in any case, you can see that there are a lot of options here. There's an ARP packet. And another thing I wanted to show you is, for example, if you're looking for, let's go back to a DNS, UDP port 53. So here, if you double click on a packet, you get to read it and open the specific packet that you're interested in. And you have the frames here, you have all the different layers of that packet. So first of all, there's the interface, the time of the arrival, epoch time for Linux as well, time and date, times captures, UDP, as you can see, that's the protocols in that frame. It's Ethernet, IP, UDP, DNS. That's the UDP part. Okay, so here for the Ethernet we have the MAC addresses of the source and the destination. You can look for that as well. This is how it is represented in the actual packet in hex and then an ASCII. And then we move to IP, which is the Internet Protocol, and here we have more information. Of course, that's the source and destination of the IP addresses here. We have some headers and some fields here. Services, the length of the packet is here. We have the flags, which are do not fragment in our case. Checksums, of course, for validation. Source and destination again. Then we have the UDP part of the packet, which is the one that is showing the port and everything. So we have the port, source and destination, again the length, the checksum and everything else. and then we have the actual packet here, and this is what we are looking for. These are the flags, queries, and here's what are we querying for. msidentity.com, it's a type A DNS entry, and then the answers that we got here are from the DNS server, and that's the information here. So again, this is pretty much the basics of WireShark. There is a lot here to learn, and if you have the time, definitely go ahead and research it, and it will be very useful and very helpful for you. So thank you very much for watching. I hope you learned something new this time, and I hope you like it. And of course, if you did like the video, just hit the thumbs up and subscribe for more videos. We'll be happy to show you more tools like that. And I'll catch you in the next one. Thank you very much, and goodbye.